Assalamualaikum. So we continue with chapter 2, frequency modulation part. Average power of the FM signal. One of the most important differences between FM and AM is the distribution of the power in the modulated wave. In FM, the total power in FM is equal to the power of the unmodulated carrier, which means the sidebands do not add power to the composite of modulated signal. The equation PT is equal to PC, which is also equal to VC squared over 2R. Therefore, the power originally from PC is distributed among the carrier and its sideband frequency, and it is given by this equation. PT is equal to PC times J naught square plus 2, the summation of N equal to 1 up to N equal to N Jn squared. PT, the average power or the total power, PC, the unmodulated carrier power, J0 is the relative amplitude of the carrier, and Jn is the relative amplitude of the sideband. We have looked at this in the previous part. Okay, next part is type of FM. The first one, we have narrowband. If the modulation index of FM is kept below 1, then the FM produced is regarded as narrowband. Lower the modulation index, lower the number of sideband are produced. Alright, so the lower the number of sideband, the narrower the bandwidth of the FM produced. So these are the criteria of the narrowband. The first one, the modulation index MF is less than 4. The frequency deviation is between 5 kHz to 10 kHz. The bandwidth is between 10 to 30 kHz. The modulation index, the maximum modulation frequency is 3 kHz, and it is used for speech and data, and it is used to compete with AM in various types of public service such as police, ambulance, and taxi. So the next part. The next type is wideband FM. The modulation index MF is bigger than 4 or between 5 to 2000. The frequency deviation, the maximum is 75K. Bandwidth is approximately 15 times higher than narrowband. The modulating frequency range from 300 Hz to 15 kHz, and it is used mainly for high quality transmission like FM broadcasting and also television audio. Okay, next part we will look at the advantages of FM as compared to AM. The first one, all the transmitted power in FM is useful, whereas in AM most of it is in the transmitted carrier, which contain no useful information. In FM, it is possible to reduce noise further by increasing the deviation frequency, and in FM also it provides greater protection from noise for the lowest modulating frequency. Okay, in FM, guard bands are provided between the adjacent channel to avoid or reduce channel interference. And lastly, in FM, the transmitted amplitude is constant. This characteristic has advantages of significantly improving immunity to noise and interference, which means FM signal to noise ratio is higher. And the next part is the advantages of FM compared to AM. The first one, the coverage area is smaller than AM. Secondly, equipment for transmitter and receiver are more expensive and complex. And thirdly, a much wider bandwidth is required by FM, which is up to 10 times larger than needed by AM. This is the most significant disadvantages of FM. Okay, all in all, advantages, less distortion, less radiated power, and low interference between neighboring stations. Whereas for disadvantages, it has wider bandwidth is required, it is complicated and also expensive transmitter and receiver. Okay, this is the FM versus AM. FM has constant amplitude, whereas AM has constant frequency. Frequency range for FM is 88 to 108 MHz, and for AM is from 535 to 1605 kHz. Okay, bandwidth for FM is 200 kHz, with the equation B is equal to 2 times N times FM. N is the number of sideband, FM is the maximum frequency, and for AM, bandwidth is equal to 10 kilohertz, B is equal to 2 times FM. FM has guard band between two adjacent channels to prevent interference between them, and AM, we don't have the guard band, therefore channel interference can happen. This is the waveform for FM, and this is for AM. We have constant amplitude and varying frequency for FM, and varying amplitude and constant frequency for AM. FM has low level power, AM has higher power level, and the equipment for FM is more expensive as compared to the equipment for AM. Okay, next. This is the frequency spectrum and also the equation for FM, and this is for AM. For power, PT is equal to VC squared over 2R, which is equal to PC, carrier power, and for AM, PT is equal to PC 1 plus MA squared over 2. Okay, FM, the signal to noise ratio is better, and for AM, it has low SNR value. Okay, FM operates in very high frequency band. It works in line of sight and the coverage area is smaller. And for AM, it works in medium frequency band. It's used skywave or ground wave propagation, and it has larger coverage area. So next, this is the tutorial 1, and this is the tutorial 2. So I want you to do these 2 questions, and we will discuss during our next class. Thank you very much.